Okay, Assalamu alaikum. Welcome back. So what I want to do in this session, inshallah, I want to again quickly review and complete coroutine programming model and then show you how it is used for interacting and accessing web API. So the coroutine programming model relies, first of all, it relies on suspend functions. So what is a suspend function? Suspend function is a function that can, when you execute it at certain point, it can suspend, and at later time it can resume. And while it is suspending, it's not blocking the thread in which it is running. So suspend function, think of it as the experience of reading a book, especially with our busy schedule. When we read a book, we might not have the opportunity to read it cover to cover. So what we do is we start reading and then we get called on some other things. Maybe somebody call us for dinner or lunch, or maybe we have an assignment or we have a lecture. So what we do with that book, we take the book and we suspend the reading. It doesn't mean we throw out the book and khalas, we finished. We basically put a bookmark on the book, and then at a later stage, when we get the chance, we will resume reading, and we keep reading until certain suspension point. If we have some other commitment, we mark where we reached, and then we continue reading in the future. So this is exactly what suspend function is. So it's a new thing. So it will take you some time to really grasp the concept because it is new. Because you have been always doing functions, and the traditional function is that you call it, you wait for it to finish all the work, and then it returns you the results. And while you are calling it, the caller will block. So those are conventional functions. But suspend function is different. Suspend function, you call it, it might suspend for some time and then come back and resume the work. It might suspend again, come back and resume the work. No problem. It can suspend and resume multiple times. So that is the foundation of coroutines. Now, once you create these suspend functions, and by the way, suspend function is nothing but a function that has the keyword suspend in front of it. So for example, in here, I have this get stock code. This is the suspend function. It will be running on the IO dispatcher on the background thread. And it basically does two jobs. It gets the stock symbol, because if I give it Apple, for example, I want to get the stock code for Apple. I need to first to get the symbol of the company Apple. And then based on that symbol, I'll go ahead and get the price. And then I'll return the symbol and the price. So this is a suspend function. I mark it as suspend, and it's calling other suspend functions, which is get symbol and get the price. So this is a suspend function. In here, I'm just simulating the suspending by using delay. But in a real scenario, I might be calling some remote service on the web, and I'm not going to block to wait for it. The function will suspend. When the results come back from the network call, the function will resume execution. So suspend function is a function that is marked as suspend, and at certain point during the execution of that function, it will suspend and then later on resume execution. That's basically the idea of suspend function. Now, once you create suspend function, you can only call it from another suspend function or from a coroutine. Now, what is this coroutine? So, first of all, to create a coroutine, think of it as a container where your suspend function will be running. And to create a coroutine, you need a coroutine scope. just be patient here. It will come. The idea will come to your mind slowly but surely. So why do the Kotlin people forced us to call the suspend function inside the coroutine scope? Why can't we just call our suspend function like other normal functions? For example, why can't I just go to here, get my suspend function, and call it inside my main? This is not normal main. Let me just why can't I just say main create an object and call the function? Why I cannot do this? It says here suspend function should be called only from a coroutine or from another suspend function. Why is this? Any idea?
Because then the suspend is useless. Would be useless if you called it from a non-suspend function.
No. Why it's useless? I mean, I basically can say here val code, and I say equal, and I get my code. No, it's still useful. I can get the stock code for Apple by doing this. Why not? Why is it forcing me to run this inside the scope?
Because then the function has to continue until this function finishes?
No, not really. Why is Kotlin really basically forcing me to be disciplined and forcing me to really run this inside the scope? So for example, by the way, I can quickly create a scope here in front of you. So here is a scope equal coroutine scope, and I want this to run in the IO thread. And then I can basically come here and say scope.launch, and inside this scope I can launch this. And now Kotlin is happy. And I can also assign this to a job equals. Why Kotlin is forcing me to run suspend function inside scope? They could have no problem. They could have allowed us to do this. Why they force us to run it inside the scope?
So we can cancel it later?
Thank you very much. That is the idea. Very, very important concept. Is the idea to be able to cancel this job if I need to. And I will explain why. So job.cancel if I wish. So imagine in our case, for example, let me just show you here. I have this Fibonacci here running. It's generating, this is a long running task. It will go on forever if I don't cancel it. And basically at certain stage, if the user wish to, they can cancel it, no problem. But if I run it, let's say if I run it here, how can I cancel this? This is a function running. How can I cancel it? There's no way to cancel it if I don't put it inside the scope. So to cancel it, I need to run it inside the scope. Is clear? That's one reason. We will see more reasons why. Okay, so for me to run a suspend function, I need to run it inside the coroutine, and to create a coroutine, I need to do it using a scope. So what's going on here? You see here, I created a scope. Then using the scope, I launch a coroutine, and inside the coroutine, I am running this particular task. Yes. And this gives me the ability to cancel if I wish to do so. Now, this canceling is very important in the context of Android mobile development. So imagine the user is using the app and they are interacting with the app using a particular fragment or screen, and suddenly they decide to click back, and this activity or fragment will be destroyed. We don't want this long-running task running in the background to continue. Why we don't want it to continue? Why is it important to cancel a long-running task running on the background when the user navigates away from a particular fragment or particular activity? Why is it important to cancel a long-running background task?
Taking memory.
Sorry?
Taking memory usage.
Yes, it's doing memory usage, it's taking computing power, it's draining, it might be draining the battery. If it's talking to a remote server, it might be using bandwidth and making Ooredoo richer. We don't want all of this. If we close a particular fragment or activity, we want to basically cancel the long-running task. And we want an easy way to do it, and this is where coroutines really excel. If you want to do this using threads, it's much harder. So coroutines, they are very lightweight, plus they give us this ability to cancel. And this is important, not only for memory and for battery life, also when this background thread is finished, and it want to call back the main activity or fragment, the activity or fragment to report the results. That fragment is already destroyed. You might get a null pointer exception. Your application might even crash or have memory leaks. So that's why it is very important when we run something long running in the background, we need to be able to cancel it. And look at what Android even give us. They give us even very powerful built-in scopes. We don't need to create our own scopes. I can, of course, create my own scope if I wish to, but I don't need to. In real life, in a real application, I can use built-in existing scopes. So in here, if I want to launch a coroutine inside a view model, I should do so inside the view model scope, and I go ahead and launch the coroutine. Now, the advantage of this, of course, I can always do here val job equal, and at certain stage I can go ahead and do job.cancel. Of course, I can do this manually if I wish. Not only this coroutine here, if it is incomplete by the time this job is by the time this view model is destroyed, it will be auto-cancelled. All the incomplete coroutines placed inside here will be automatically cancelled, even if I don't want to cancel them, even if I don't cancel them manually, they will be automatically cancelled. And this is very important because the developers, they tend to be lazy and they don't do cleanup. They just basically focus on getting things working. They are in a hurry to get things working. They don't care about cleanup afterwards. So that's why Kotlin is trying to put some discipline for us as developers. Say, okay, I will force you to use a scope. And then, khalas, once you use a scope, don't worry, you don't need to cancel. If the object is destroyed, I will cancel on your behalf. So the view model scope will automatically cancel anything that is still running by the time this view model is destroyed. So I hope it's clear. Same thing if you want to run some coroutine in an activity or fragment, you have this built-in scope called lifecycle scope, and all you do is you launch your coroutine inside this lifecycle scope. And what will happen when the fragment is destroyed and no longer needed? What will happen to the incomplete coroutines that were launched inside this scope? They will be automatically cancelled. There's a lot of powerful things going on here. I hope you appreciate what you are seeing here. Okay. There are other ways you can run suspend functions. You can run suspend functions inside scope. You can also run them inside the live data. I'm sure you have seen this. If you have if you have a suspend function, you can basically run it inside the live data, and when you get the result, you emit the result. So what will happen? Anyone that is observing this variable, they will get this value. So that's another way of calling a suspend function. You can either call it inside the scope or you can call it inside the live data. Now, the scope gives us two functions to be able to launch a coroutine. You can either use a launch. We call these functions coroutine builders functions, builder functions. So you can either use launch. Launch allows you to call a coroutine and in a fire and forget fashion, which means you just call it and you don't really care about any return value. And if you really need to get a return value, then you use async instead of using launch. Okay, so let me show you this. If I go ahead here, what I can do here, I can basically call this inside an async. So I'm launching this inside an async, and this will give me a future value. I usually call it deferred, which is basically this will not give me an immediate value. So the return here is basically a deferred stock code. It's not an immediate. In the future, I will get this. And basically what I can do, I can basically go ahead here and await for this to come back. And in here, I will get my code. So I use async coroutine builder. I use this async coroutine builder if I'm expecting a return value. So this will return me a future value, and then I use that future variable to basically await for the results. So this will suspend the execution until the results come back, and then I will get this code at my hand. Now, if I use launch, then there is no wait. خلاص. I just use launch. This is basically, let's say, job. Wait just a second. I rename this one as parent job. So inside the scope, I can launch multiple jobs. So in here, I'm not expecting any results. I can, of course, I just fire this and forget about it. I'm not going to collect the results. I can, of course, come at a certain stage and cancel if I wish. But I'm not going to collect the results. I'm just going to launch this coroutine, and that's it. I'm not going to wait for the result to come back. If I want to wait, if I'm expecting a result and I need that result, then I use async instead. So if I use async, then I can wait for it. Or even with this async, I can cancel if I wish. I can cancel if I wish. So let me summarize what I just said. So in a coroutine scope, the coroutine scope offers us two builder functions to create and start coroutine. Either I can use the launch method, and this is used for fire and forget. Start the job and let it go and not worry too much about the return value. Allahu Akbar. Or I can use an async routine build, coroutine builder, and in this case I wait for the result to come back. Okay, so I hope it's clear. So the difference between the two, this is fire and forget, and this one will return a value, future value. Okay, so the other thing I can really do with the scopes, with coroutine scope. So one advantage of using coroutine scope is that I can cancel the job if it's no longer needed. The other thing I can do, I can run multiple coroutines in parallel. So I can either go for parallel execution or I can go for sequential execution. So let me show you this. Let me just remove this and show you two implementations. So in here, let me run it while explaining it. So in here, what I'm doing, I'm basically launching this coroutine, and inside it, I get the code for Apple, for Tesla, and for Google. And I'm doing this sequentially, one after the other. Calling this, getting the result, displaying it, calling this, getting the result and displaying it, calling this and getting the result of displaying it. Of course, when the execution reach here, because this one is a long running, you can see it is a suspend function. The execution will suspend. When the results come back, I resume and display the result. Then I suspend to get the results for Tesla. When the results come back, I display them. Then the function will suspend. Sorry, the coroutine will suspend at this until the results for Google come, and then we display it. So in here you see this is sequential, one after the other. This is the Apple price, then Tesla, then Google, and this took 10 seconds. Now let me show you another version which is done in parallel. And basically what I can do here now, I am doing this in parallel, getting all the three in parallel, and I'm getting all the prices in parallel, and it took 3 seconds. So third of the execution time. So it's much faster. So how do I run things in parallel? So inside my scope, I launch a scope, and then in here I'm launching three parallel coroutines. The first one, I'll get the stock code for Apple. The second one, I'll get the stock code for Tesla. And the third code, I get stock code for Google. And basically, I launch them, the three of them in parallel. Then I go and wait for the results to come back. So it will suspend. When the results for Apple come back, I'll display it. Then it will suspend. When the results for Google come back, I display it, and so on. Okay, so that's why this is done in parallel. Now, if I move this up here, you need to be careful. If I move this here, this is no longer parallel. This is now sequential. In fact, I should use this to replace the other thing. Sorry, just to make sure. Sorry, just a second. I just want to replace this. This is a really sequential. Let me just run it quickly. This will still take 10 seconds if I do it this way, because I am launching this coroutine and suspending until I get the result. And I'm launching this coroutine and I suspend until I get the result. And you can see here it took 10 seconds. Now the parallel version, the true parallel version, let me just go to history and get back my the true parallel version. Yes, this is the parallel version. Let me just revert to this one. So the parallel version, as you can see here, I launch the 3 routines concurrently, then wait for the results. So be careful the difference between the two. So let me run this, and you will see this will take 3 seconds instead of 10. So that's another advantage of using coroutines and launching my coroutines in scope. I can run multiple coroutines in parallel. I launch them and then wait for the results to come back. So I hope it's clear, this parallel execution that coroutines allow me to do. Cancellation, I already explained it. I can either explicitly cancel the job, or I can wrap the job inside this with timeout. So what happened here, I give the chance for this long-running coroutine to work, to do its job, and if it doesn't respond within 5 seconds, it will be automatically cancelled. So let me show you a running example of this. You see this Fibonacci will run forever. Will run forever and give me a series, but after 5 seconds I will cancel it after 5 seconds. So let me run it and I will show you. So I did not explicitly call job.cancel, but I just wrapped it inside this with timeout or null. You can see here after 5 seconds it was cancelled because the job it took longer than 5 seconds. So you can either cancel the job explicitly by calling the cancel. That's one way of doing it. Or you take the coroutine or the suspend function in this case and wrap it inside with timeout or null. If the job is cancelled in the future, the job will be null, and you can recognize that the job is cancelled. If the job is not null, then the job finished successfully and it was not cancelled. So you can see it's a very, very powerful way of cancelling after timeout period. Now, the last thing I want to show you is exception handling. So by default, if you have a parent job, let me call this one parent job. I think it's much nicer. Parent job. So my scope is basically a parent job, and inside this parent job I create multiple jobs. You can see here I create multiple jobs. If one of them fail, for example here this one will fail because instead of putting apple with double P, I put apple with one P. This will fail. So by default, if I have a job that has multiple children jobs or child jobs, if one of them fail, the whole parent job will fail, and the remaining incomplete jobs will be automatically cancelled. So this is the default behavior. So let me show you this concretely. Here is the exception handling. So I run this job. If there is anything wrong that happens, when I launch it, I give it an exception handler. And if there is any exception, you can see a very nice model of handling exceptions. So I pass to it when I launch this big job. Let me just rename this to parent job, just to make it clear. Parent job. Okay. Now, when I launch this parent job, I can pass to it an exception handler. If there is any exception that happens inside this parent job, this will be called and this message will be displayed. Now, by default, because this parent job has many child jobs, you can see here I have child jobs here. If any of them fails, the whole jobs in this scope will fail. And the remaining, for example, if this one fails, this remaining job will be cancelled. So let me show you here. So I run this, and it will successfully get Tesla price, no problem. And then it will try to get Apple price, and it will fail. And because this one failed, the whole job failed, and the price for the price for Google was not even attempted. Okay, now this is the default behave. If I don't like this default behave and I want this to continue, the parent job to continue and not fail if one of the children fail, then what I need to do, I basically wrap these child jobs inside something called supervisor scope. So if I use a supervisor scope, if one of them fails, the job will continue execution. So take a look at this. I run this, and basically Tesla will be successful and I get the price. Apple failed and the price was not received, and then Google continues. Okay, so that is the idea. So by default, if a child job fails, the whole scope fails and remaining incomplete coroutines are cancelled. If you don't want this behave, you need to wrap your jobs, your child jobs inside the supervisor scope, and this, in this case, if one of the job fails, it doesn't affect the remaining jobs. Okay, so let me just summarize everything I have discussed in one slide, this very, very important slide here. So the way coroutines are done in Kotlin, you need to run coroutines inside the scope. And this is a disciplined way of doing it. And it's also called structured. This is a new powerful concept called structured concurrency. And what structured concurrency means, it's a disciplined way of doing concurrent programming. First of all, you are forced to run every coroutine inside the scope. And once you do this, once you do this in this scope, you have a scope which represents a parent job. Any child coroutines you start inside the parent scope will be considered as children coroutines, and the parent coroutine will only complete until all the children are completed. If you cancel the parent, the children gets cancelled. If one of the childs fails, the parent will fail and the incomplete siblings will be cancelled, unless if you wrap the child jobs inside the supervisor scope. Okay, so in 3 words, I will summarize everything we have seen. So with coroutines, you have now at your hand a very powerful programming model. You can cancel computation if you don't need it anymore. With normal functions, you cannot do so. You can run computations in parallel very easily, as I showed you. You can also handle exceptions in a more powerful way. You can either, by default, if you have multiple jobs within a parent job, if one of the jobs failed, if one of the child job fails, by default the whole scope fails, unless if you don't want this behave, you can wrap all the children coroutines inside supervisor scope. Then in that case the parent job will still continue despite the failure of one of the child coroutines. So basically you really need to go through these slides very, very carefully and go through the examples provided. Every concept covered in these slides, there is 1 or 2 examples further illustrating the concept. Okay? All right. Now, let's start seeing applications of these coroutines, how these coroutines are applied in other aspects of Android programming. The first thing is flow. So this is another very, very powerful programming construction you have at your hand. So we are used to, when we call a function, we get a return value and that's it. Function is finished. Now with flow, you can get a function to return you multiple values over time, not in one shot, but in multiple shots. So let me show you this. So what I have in this very simple example, so I have here some prime numbers, and I want this function to return me 2, and then after 100 milliseconds return 3, then wait a few seconds and return another value, and so on. So this is simulating some kind of remote service that is pushing to me some values over time. So how do I create a function that returns multiple values over time? Is I wrap that function inside the flow. And then in the main, I can basically collect those values over time. So let me just run it first and I will explain it further. So in here you can see I'm starting to receive these values one by one over time. So it's like a list, but in a list, you are familiar with the list. You have seen lists before. So for example, this is a list. The issue, like here, a list, you can get all values in one go. Khalas, here's a list, here's the values. But a flow is values that you will receive not in one hit. You will receive them gradually. So the function will give you one value, it will suspend, and later on give you another value, suspend, and give you another value, suspend, and so on. Okay? And you can also consider these flows like a list, and you can basically filter them if you wish. You could transform them before you collect those values. So similar to a list, you can apply all the map, filter, reduce functions that you have already seen. Not only this, you can also ask the flow to run. You want this flow to run on a background thread very, very easily. You say, please produce this flow, but don't use the main thread. Use a background thread. All you do, you say flow on, and you specify which thread you want this flow to run on. And this will be running in the background. So let me run this. So you can see here, I will be getting these values. You can see here I'm getting these values over time, emitted over time. And these were produced in the background thread, and I am collecting them in the main thread. So that's basically the concept of a flow. I just wanted to introduce the concept, but you will appreciate it more when we apply this concept when we deal with Web API or when we deal with database. So let me finalize this discussion with one small example. So for example, this is a tweet. So to get the tweet details is one shot operation. I go to the Twitter and get the tweet in one shot. But while the tweet is being displayed, the number of retweets and the number of likes, it's a multi-shot operation. So let's say every 10 seconds, I will get an update of how many retweets and how many likes that particular tweet has generated. So in this scenario, there is no need to use the first part. In the first part, there is no need to use a flow. But in the second part, a flow is a very nice way to handle this part here. So you can do something like this. So you could say, like every 10 minutes, go ahead and refresh, let's say, the tweet counts, the retweets. Go ahead and get me the retweets. Go ahead and get me the likes and refresh my UI. So in this case, this function is returning me a flow instead of returning me one single value. And this flow will keep repeating forever every 10 minutes in this scenario. Okay, so definitely we will come back to flows and you will see their application as we move forward through this course. Okay, that's it for coroutines. They are very, very powerful. Of course, it will take a bit of time to really understand them and fully master them. So please go through these slides. I spent so much effort crafting them. Hopefully they are as clear as I could. And every concept, there is an associated example. Both you can, some examples you can just right click and run. Some examples are embedded in this nice app here. And you can run things, for example, here, I can run this in parallel. I can run this in sequential. Exactly similar to what you see here, but using inside Android app, inside an Android app. All right. Okay, that's it for this. Now let me switch to applications where these coroutines are used. So let me show you this. One application of coroutines is the ability to use them to call remote web API. So for example, to call remote web API, on Android, there is this famous library called Retrofit. So if you, it's not from Google, it's an open source, but it's widely used. So Retrofit. So you can see here is very, very famous library, and this library uses coroutines to allow us to interact with remote web API. So let me first explain what does remote web API mean. So you can see anything we do as humans when we go to the web. Let's say I go to GitHub here, and I get, let's say, the repositories, I get the organizations. I can do this using programmatically. I can do this using web API. So GitHub has an API. So I can use, you can see here, it has a web API. I can use it. GitHub Web API, get started. Get started guide. Yes, and I can basically programmatically call GitHub services and GitHub functionality. I can call it from another program. Instead of calling it as an end user, I can write a program to call the functionality of that particular program. So, for example, I can use, I'm sure you have used this in your lab. So I can, for example, go here and programmatically call this api.github.com.zen. This will give me like a tip from GitHub team. It says here bad credentials. Oh, bad credentials, which means no problem. Let me just go off. Okay, here responsive is better than fast. Run it again. Okay, let me try another one. If I go here and say get me all the repositories for a particular person. So for example, if I come here and say GitHub / this is for the human web. I can come here and you can see I have 4 repositories. 4 repositories, for example. Now, if I can get this information also programmatically. Take a look at this. I can basically say users.eradi and then send, and this will give me the repositories that I own, and the results are coming back as a JSON document. Yeah. So basically that is the idea. So a web API is think of it as a website where when you call it, instead of getting HTML, you will get JSON format. And this JSON, of course, is more friendly for programming. You can convert it to an object, and then you can do something with it, whatever you wish to do with it. Now, all major services that we are enjoying on the web, they all have Web API to access them. For example, Google. So for example, google.com, we can search here as a human user, you can search, but you can also write a program to do Google search. So you can do Google search API, and there is an API for Google search. Google search API, and then you read the documentation and you see how to do it. For everything we do, like for example, Twitter, there is a Twitter API. You can get tweets, you can write a tweet, you can follow tweets, you can do whatever you do using the Twitter user interface, you can do it programmatically.
And also we can...
Yes, please.
And also we can use it for the login.
Yes, you can use for authentication, you can use for whatever functionality that particular service provides, you can reuse it in your application. And that's a good example you just mentioned. You can use what we call social authentication, where instead of creating your own authentication system inside your app, you can outsource that to either Google or Facebook or Twitter or GitHub. So that's why in some applications, in some websites, instead of creating an account, you can log in using social login. So for example, if I go to booking.com and I can sign up or sign in using social accounts. You see here I can log in using Facebook, Twitter, or even app. So the authentication functionality of these online services is available as a web API, and it can be reused in another app. And that's basically the idea. Okay. So a web API, the idea of a web API is that you have some resource on the web, it has a particular address, and then you can access it using HTTP verbs. So HTTP is a protocol of communication between the browser and your web server, or between your app and your web server. You are using HTTP. So you can see here, whenever I access something on the web, I use HTTP. You see here HTTP. Everything on the web, it has an address. And basically in here, the browser will send a GET request to this URL to get the latest news from Al Jazeera. Now, if you want to really see this, how it is done, it's better to use some tool like Postman, and it shows you here the verbs that you can use to interact with this URL. So you can use get. Usually get is to read from this particular URL. You use post if you want to create a new resource. For example, if you want to create a new repository, you will do post to this URL. And you post the repository details and it will be created. Or if you want to change, you use put. If you want to delete, you use delete. There are others, but they are not as important. The most important verbs used in HTTP to interact with a particular resource available at certain URL are these verbs. Basically, get is to read, post is to create, put is to update, and delete is to delete. Okay, and typically you access them, you use them against a particular URL. So for example, in here, if I say get/books, I get all the books. Get/books/ID, I get a book with particular ID. Post/books, create a new book. Put is to update a particular book, and delete is to delete a particular book. Okay. Now, you can of course test and interact with that web API using a tool like Postman, Once you are familiar with it, you can start accessing it from your Android app. So to be able to access it from your Android app, you use a library like Retrofit. There are other libraries, but Retrofit is the most famous one. It's very super easy to do. Basically, you need two steps. First, you define what is known as Service API, and then you ask Retrofit to build for you, to generate for you a client object to interact with that web API. So let me show you a very super simple example. So what I have here is a stock quote. If I want to get a stock quote, a real stock quote for a particular company, there is a web service that can do this. It's called polygon.io. There are many. I just found this one to be super simple one. So let me just use Postman. And in here, I'll say, please go ahead and give me the stock code for IBM for yesterday, the 19th of 10th. And I go ahead and run it. Of course, I have registered, no, not post, I use get. Go ahead. You see here the stock code for IBM is $129. Now I can change this and say, give me the stock code for, because I first went there and registered in this with this API, and I got this key. I must send this key, otherwise they will say, no, I cannot give you any information. I'll send here, it will say here, an app API key was not provided. So I register with this API, they give me the key, and I pass it as a parameter in this URL. And I'll send it off. Okay. Now, if I change this, I'm interested to get the stock code for Apple. For Apple, of course, it will say not found, because this is the stock name. This is the company name. If I want the stock code, I have to provide the symbol. I think the symbol for Apple is APPL, if I'm not mistaken. No. Let me see. I think the stock code for Apple is AAPL. So I'll go to that URL and go here. This is the stock code for Apple, and I basically run it. It gives me the stock code for Apple. It's basically is $119. So let me just check with Google, just see how close it is. Apple stock price 115. It even went down. Can you see it here? I think stock is crashing today. This API does not give me the most recent. It gives me 1 day before. If I try to put 20, it says here 2 days not supported yet. So I'll provide 1 day before. Okay. So you got the idea. So this is an API. I can call it to get the stock code for a particular company. Now I can do the same. In my program. So the first thing, I create an object. Sorry, I create a class. That will represent, this class will represent this object that is coming back here. Can you see it? It will represent this object. So let me show you this object. Let me just copy it. So I create a class that will receive this object. Anything I don't need, okay, status is string. I put it here as a string. Date, from. So instead of from, I don't like this from. I called it date. So what I put in my class, it will be known as date, but in the incoming message, it will be from. So I add this annotation here to say, oh, please map from to date. So this field in the JSON message will be mapped to this field in the class. And this open, for example, open, I mapped it to price. And for these, I ignored these. I didn't even add them. I still add the high and low. This is the highest price on that particular days, and this is the lowest price, and this is the closing price. Okay. Now that's it. This I created a message. Then the second thing, the second step. Sorry, I create a class that represents the structure of the message that I will get back when I call the API. The second step is I define a method that represents this call here. So what I'm really doing here, I am basically getting a stock code by going to this URL. So I created a function get stock code, and this get stock code will receive a symbol. Can you see it here? We'll receive two things. It will receive a symbol that you must put in the URL, and it will receive a date that is also in the URL. Also, it will receive a key. But in here, the key is hard-coded. I hard-coded the key here. So I put here. So when somebody, basically here, when somebody calls this get stock code, a get request will be generated, and it will be sent to this URL. Now, whoever is called this, let's say somebody comes and calls this method get stock code, and they sent, let's say AAPL, and then they sent 2020 /10/19. So what happened is this will be assigned to symbol, will replace symbol, and this will replace the date, and the API key, we will get it from this hard-coded value, and basically this part of the URL will be constructed, and a get request will be sent to the service. Now this is in here I am describing the association between the get URL and this get method. Okay, so I define the service interface. So this service that we are looking at has one function, which allows me to get a stock for a particular symbol and a particular date. That's all I do. And this function will basically return me stock market stock codes. Now, once I do this, I ask Retrofit to automatically, in an automatic way, please go ahead and generate for me a stock code service that will allow me to go to this URL here. It will allow me to go to this URL and build for me. So based on two things, based on this URL and based on this interface I defined here, go ahead and build for me a class to allow me to call this remote service. So this will be auto-generated. This class will be auto-generated by Retrofit, and then what I can do, I can basically go to this repository .get stock code, give it a symbol, give it a date, and then it will go ahead and get me the price. Okay, so that is basically the idea in here. 3 steps, just to summarize, I let you go. The first step, you define a class to hold the results of your web API call. The second step, you define an interface that maps a method with the URL. So this method, when somebody calls it, definitely they need to provide the symbol, and definitely they need to provide the date. So this symbol and these dates will be added to this string to create the URL. So at the end of the day, when somebody calls this method, a URL like this will be constructed, and this URL, a GET request will be called, similar to what we did here, exactly like this. So this will be, so in our case, this particular URL is constructed, and a GET request is sent to this service. When I do send, I get back this result. And this result has the symbol that I asked for, and it has the various prices of this particular symbol. Okay. Now the last step, this is just an interface. I cannot, of course, call this interface. An interface is not callable. It just defines, this interface defines the method, but it doesn't provide an implementation. The good news, I don't need to write the implementation myself. I just ask Retrofit, please go ahead and generate for me a class that will allow me to interact with the service available at this URL. This is the base URL. And when I interact with this service, convert the input and output, convert them from an object to JSON, convert them from object to JSON using JSON library. So you remember Kotlin has a library, if you can see here, JSON has a library called for serialization. I think it's now I think it's built in. You don't even need to import it. So let me, sorry for this confusion, just a second. So in here, I am asking Retrofit, please go ahead and build for me a client. And that's it. This client, I can use it to call the remote service. And Retrofit is the one responsible of automatically generating this client. And this client will allow me to do exactly what this Postman is allowing me is doing. It's allowing me to send the GET request to this URL, get the results. The results will be in JSON, but it will be automatically converted from JSON to an object. So you can see here this get code receives two parameters, symbol and date, and returns for me a market stock code object, And then that's it. It's a class. I can basically call it like any other. It's a method in a class. I can call it like any other method in a class. So I create an instance of the. I don't even need to create an instance because this is an object already. See here, this is an object already. I don't need to create an instance. I access this stock code service, which is automatically generated by Retrofit. And then I call the getStock method. I pass it the symbol and the date, and I get back the actual code. Yeah, so that's all for the for using Retrofit. Two simple steps: define my service API, and then the second step is ask the Retrofit to automatically generate a service client for me. And then I can use that service client to call the remote web API. Yeah. Okay. That's it for now. I think there's a lot of things going on, but I hope you got the idea because you already played with this in the previous lab, and today's lab you will play with this further. And with this, I conclude this session.